Okay, so number one, we are going to identify four sinusoidal equations that model the graph below. We have a positive negative sine and a positive negative cosine. So the first thing that you're going to want to do is identify where the middle point is here, or the middle line. And in this case, it goes right through the x value of 1.5. Okay, so there are three things that are going to be the same for every graph. Your a value, your b value, and your d value will all be the same for each graph. Your amplitude is never going to change. In this case, your amplitude is half the height of the whole graph, so the height of the whole graph is 3. So your amplitude is 1.5. Your b value is going to be the period of the function, so you need to identify a full cycle. So in this case, the easiest thing to identify is a cycle from here to here. Okay, you were also given that this was 3 pi. So therefore, you know that this point here, from one starting point to another starting point, the entire period is 3 pi. So to identify b, you have to set it equal to 2 pi over b. Solving for b will give you 2 pi over 3 pi, which the pi's will just then cancel out, and you'll be left with 2/3. Your d value is your vertical shift, so how far is the midline moved up? The midline is moved up 1.5. So all of those are the same. So let's start with the positive sine graph first. The first place that you find a positive sine value is right here. So you have to determine how far that is shifted to the left. Okay? That's going to be a little bit tricky because you know that the graph touches down or has an entire period of 3 pi. So you're really trying to find the point in between. If you notice that the x value is right in between negative pi over 2 and negative pi. So how do you find right in between two values? You have to average them. So in this case, you actually have to average all of those values in order to find what the value of the x is for the phase shift. So negative pi plus negative pi over 2, that's really going to be negative 3 pi over 2 divided by 2, which then, if you simplify that with fractions, it's going to be equal to negative 3 pi over 4. So your phase shift for the positive sine graph is going to be negative 3 pi over 4. So that's basically your c value for the positive sine equation. So your positive sine equation will be y equals the a value of 1.5 sine, parentheses, b, which is 2/3, parentheses, x, since it's negative 3 pi over 4 for your phase shift, you're actually going to do plus 3 pi over 4. And then your vertical shift is 1.5. Alright, so the next one, if you just move along the curve, the next point that if you go up to the top here, this is going to be a positive cosine graph. So let's go now to the positive cosine equation. Again, a, b, and d are all the same, and there is no phase shift here. So this equation is going to be a little easier. Y equals 1.5 cosine. And in this case, it's just going to be 2/3 x, because there's no phase shift, and then plus 1.5. If I then move to the next point would produce, see, I go down first and then come back up. If I continued it, this would be a negative sine graph. So my next equation is going to be a negative sine. So negative sine. And again, for this one, it's going to be almost the same exact as the one right above this, but it's going to be negative 1.5 sine 2/3 x. Now, instead of this time it being plus 3 pi over 4, it's going to be minus because it shifted to the right 3 pi over 4 this time. So now it's going to be minus 3 pi over 4. Oops. And then plus 1.5. Finally, my negative cosine, I'm going to move now to this point. So again, I pick a starting point for each of my positive, negative, cosine, and sine graphs. So this one's going to start at 3 pi over 2. That's your phase shift. So now your negative cosine graph is going to be y equals now negative 1.5 cosine, still 2/3 x, and this time it's going to be 3 pi over 2 is your starting point, so minus 3 pi over 2 plus 1.5. And those are your 4 equations. Okay, so for number 2, we are graphing the inverse tangent graph. So it's going to be basically a reflection over the line y equals x for tangent. So your original tangent graph goes from negative 1 to 1 and from negative pi over 2 to pi over 2. And if you remember, I'm sorry, I should say that the other way around, your original graph is going to look like this. Okay, these are going to be asymptotes. And remember, our tangent function is restricted from negative pi over 2 to pi over 2. So this is what the graph is going to look like originally. Okay, notice negative pi over 2 here. And so now we're just basically going to reflect it. And then when I do that, the axis also flipped. So now, instead of going from negative pi over 2 to pi over 2, I'm going to go from negative 1 to 1. And I'm going to go from negative pi over 2 to positive pi over 2. Okay, now your asymptotes now run horizontally. Okay, and now your graph is going to just be, imagine drawing it sideways, like this. Okay? Yes? Okay, so now to graph y equals 3 times the cosecant of x plus pi. For this graph, we actually are going to first graph the associated sine-cosine function. So the reciprocal function of cosecant is sine. So I'm really going to first graph the graph 3 sine of x plus pi. So I have to identify A, B, C, and D in order to graph this. So my amplitude here is 3. My B value is 1. I don't really have any vertical or horizontal shrink or stretch. My C value, I'm moving it over pi. It's actually going to be a minus pi. I'm moving it to the left pi. And my D value, I'm not moving it up at all. So I know that the middle remains right here on the axis. I don't need to change anything about that. My amplitude is 3, which means I go up 3 and I go down 3. So you do need to label those points 3 and negative 3. This is a sine graph, but it has a shift to the left 3 pi. So I'm actually, instead of starting at 0, 0, I'm going to start over here at negative pi. So my graph is going to start right there. Okay. Now, from there, my next value, it doesn't have a vertical shrink or stretch, so I know at negative pi over 2, it's going to go up to 3. Right there at 3. And then it's going to come back down here. And then at positive pi over 2, it's going to go down, and then back up at pi. So again, my graph is going to have a smooth curve. And you do want to try and repeat a couple of more cycles here to the left and right. So now it's going to go back up, come down, and it's going to continue that pattern of up, back to the middle, down, back up, etc. Okay. So now once I've done that and I have that graphed, I need to draw my asymptotes. So my asymptotes are going to be wherever the original sine function crosses through the x-axis. And you do need to label those asymptotes. Okay, so this is going to be the asymptote of x. And if you label a couple of them, that's sufficient. This is going to be x equals negative pi. This is going to be x equals 0. This is going to be x equals pi. You would have another one here if you wanted to continue drawing. This one would be 2 pi, and then you would have another one here as well. but if you have 3, that's fine. I think that's sufficient. So now you're going to draw on your parabolas. And that's the main part of the graph that we're interested in. So let me go ahead and do that in another color. Okay, remember those parabolas, they're ones we're interested in here because we're really graphing that cosecant function. The sine function was just so that we could get a feel for the graph. Sorry, it's a little bit messy. This is what it's going to look like. Okay, you also want to make sure that you can label some of these vertices. Again, not labeling all of them. If you have your axes labeled, then these points really aren't as critical to label, but it is a good idea to go ahead and get in the habit of doing it. So this vertex point right here is going to be negative pi over 2 comma 3. Just so that I know that you know where the vertices are. This vertex right here is going to be pi over 2 negative 3. And then this vertex right here is going to be 3 pi, 3 pi over 2 comma 3. So just labeling a couple of those axes points, or vertex points. Okay, so you want to do the same thing for number 4, but in this case you just want to graph the associated cosine function, since secant is the reciprocal function of cosine. In this case you really only have one transformation. Well, you kind of have 2, I guess. In this case your amplitude is 1/2, and it's also a reflection. So you are going to have to reflect this graph as well. The b value in this case is just going to be 2 pi, because there is no and your c value is going to be 1, and your d value is going to be 0. So everything is typical about this function, except for the amplitude is 1/2, and it's going to be reflected over the x-axis because of the negative. So you can go ahead and set up your graph. So this is going to be positive 1/2. This is going to be negative 1/2. Switch to a thinner pen. Actually, I'll go ahead and do this in black. So your graph is going to start at its typical place, except for it's going to be reflected over the x-axis. So instead of your cosine graph being up here and going down, it's going to actually start here. Okay, your period is still 2 pi, so it's going to go out to 2 pi. This is still going to be pi. This is going to be pi over 2. This is going to be 3 pi over 2. Okay, so now I'm going to complete my graph. So it's going to go up here. And then same thing over here. And then I can draw my curves. Okay. Now, again, that's not the graph I'm most interested in, I have to put in my asymptotes. And then I have to actually draw the parabolas, which is the one I'm most interested in here. You want to go back and you want to make sure that you label your asymptotes and some of the vertices of your parabolas that you draw. So this is going to be x equals 3 pi over 2. This is going to be x equals pi over 2. This is going to be x equals negative pi over 2. And this is going to be x equals negative 3 pi over 2. And then some of the vertices, if you want to label this point here, that's going to be negative pi comma 1/2. And this point here is going to be 0, negative 1/2. Etc. So just to clarify your b value is actually 1 because the period is 2 pi. So since your period is 2 pi, the b value is 1, and c is equal to 0, and that means d is also equal to 0. Okay, let's move on. So for 5, 6, and 7, this is just the range, which you can take straight from your notes. The range of each arc function is the restricted domain of the original function. So your restricted domain of sine is from negative pi over 2 to pi over 2. Your restricted cosine is from 0 to pi. And your restricted of arc sine is the same, except for you do not include the values of negative pi over 2 and pi over 2. Sine inverse of root 3 over 2, you would need to think of where you get a sine value of root 3 over 2 on your unit circle. It's probably helpful just to kind of sketch out that first quadrant. If you don't already have it memorized, that would be helpful. And put your the major points, those 5 major points from the first quadrant. Okay, I also like to even include the tan values there. But where sine is root 3 over 2 is going to be the second point, and that would be right here at pi over 3. So the sine inverse of root 3 over 2 is pi over 3. The tan inverse of root 3 is going to be at the pi over 3 as well. And again, you get tan by doing sine over cosine. So root 3 over 2 over 1/2. 2's will cancel. We're going. Okay, so for number 10, you're looking for the cosine inverse of negative 1/2, so that has to be in the second quadrant. So that's going to be the where you get the cosine value of 1/2, which is going to actually be a reflection of right over this axis here. So that's going to wind up being 2 pi over 3. The inverse tangent of negative root 3 over 3, that means you're in the fourth quadrant, which means you're going to state it as a negative pi over 6. The arc sine of negative 1, so where do you get negative 1? You get that at negative pi over 2. For number 13, this is something you're going to have to plug in your calculator, or you could actually set up a triangle for it, but any like this you can just plug into your calculator. There will be a calculator in non-calculator section on your test. So 0.698. Cosine inverse of cos of pi over 3. So you first are going to find the cosine of pi over 3. The cosine of pi over 3 is 1/2. And then if you take the arc cosine of 1/2, it's just going to give you back the same thing of pi over 3. So in this case, the cosine inverse and the cosine just kind of cancel each other out and you're left with pi over 3. This one is a little bit more tricky because you can't just cross each other out like you could over here. The reason is because if you take the cosine of negative pi over 6, you're really looking at root 3 over 2. Because in the fourth quadrant where negative pi over 6 is, cosine is positive. So you're really taking the arc cosine of root 3 over 2. Well, when you're taking the arc cosine, you're only restricted to the first and second quadrant. So now you're looking for an angle in the first quadrant that has a value of root 3 over 2, which is going to be pi over 6. So as you can see, because of that restricted domain, or actually range in the arc cosine values, you're going to wind up with a positive pi over 6. Down here, the tan and tan inverse will cancel out. And for number 17, you have to draw your triangle to figure this one out. So the sine of 3, if I take sine, that's opposite over hypotenuse. If I use Pythagorean theorem, my missing side is 4. Tangent of this angle is opposite over adjacent, so you actually get 3/4. So this is just using a triangle. Alright, so in this problem, you have you're aboard a submarine submerged in the Pacific Ocean. At time 0, you make contact with an enemy destroyer. Immediately you start porpoising, which is going deeper and shallower. After 4 minutes, you are at your deepest, which is 1,000 meters below sea level. After 9 minutes, you reach your shallowest, which is 200 meters below sea level. Assumed depth varies sinusoidally with time. So you can kind of set up your x-axis here to be time. And you know, after 4 seconds, which is right here, you are at your deepest, which is at negative 1,000 feet. You also know, so after 4 minutes, you are at negative 1,000 feet below sea level. So you're going to put a point there. And 5, 6, 7, 8, 9. At 9 minutes, you reach the shallowest, which is 200 below. So here's your negative 200. So then you have to kind of complete your function. Notice that this is only half of a negative cosine. So this is only half of a negative cosine, so you have to finish it. And if you notice, between 4 and 9 is 5 minutes. So you have to count 10, 1, 2, 3, 4. Another 5 minutes is going to be 14 minutes. So you know, then you're going to reach your deepest again at 14 minutes. So there's going to be one complete cycle of this situation. Okay. Now, you will want to try and label these points. 4, negative 1,000. This is 9, negative 200. And you're also going to want to find that middle line here. So how are you going to find the middle of this function? You are going to average negative 200 and 1,000. So in between is going to be negative 600. Okay. And now this pattern is just going to keep repeating until you get out to 30 minutes. Okay? Alright, so you're going to want to continue this out. So 24, 25, 26, 27, 28, 29, and then 30 is going to be your last point, because you're supposed to graph it for the first 30 minutes. Alright, so again, every 5 minutes you're going to have another portion of your graph. So this is going to be at 19 minutes, you're at 200. At 24, you're back down at 1,000. 29, you're back up at negative 200, and you can complete your graph. Now this is going to be one that you can use a calculator for. So you're going to want to now use your calculator to find an equation for this function. Okay, you also want to try and label some of these points here. So this point is going to be 6.5, between 4 and 9 is 6.5, comma negative 600. This is going to be between 9 and 14, which is 11.5, comma negative 600, etc. Okay, so answering some of these other questions over here, write an equation to model the situation. So again, you need to find A, B, C, and D. All of those values are important. Your amplitude is half the height of the wave. So your wave goes from negative 200 to 1,000, which is 800. Half of that is 400. So your amplitude is 400. Your B value is going to be 2 pi over B. You're going to use the definition of a period. And you know that your period in this case is how much it takes, how long it takes for one complete cycle. So if I start with that original cycle from 4 to 14, that's 10 minutes. So I know my period is 10 minutes. So 2 pi over b equals 10, which means b is equal to pi over 5. So b is pi over 5. Your c value is your phase shift. So in this case, how far is that first point shifted over if I'm going to use the negative cosine function? Shifted over 4. So your c value in this case, since I'm using the negative cosine graph, is going to be 4. And then finally my d value is how far it's shifted up or down, and in this case your midline is shifted down 600. So d is negative 600. So therefore when I write my equation, remember I'm modeling it after a negative cosine. So negative 400 cosine, parentheses, pi over 5. You can use your variable, you can use t for time, minus 4, because it shifted 4 units to the right, and then minus 600, because it's 600 down. Alright, here would be a good place to put it in your calculator. Okay, so in your calculator you're going to put in negative 400 cosine, parentheses for pi over 4, or sorry, pi over 5. Then you're going to do your t minus 4, or in this case x, because we don't have a t, and your parenthesis, then end the parenthesis for the whole cosine function. minus 600. Now you're going to have to set your windows here. So go to your window. So you want to start with an x min, which is the lowest x value. In this case, you're not going to go past 0. Your x max is going to go out to 30 minutes because you're graphing the first 30 minutes. Your y min is going to be negative 1,000, but let's have it go just a little bit below that. And then my y max, we can just make 0 so that we can see the axis. So then if you graph it, oops, something I didn't put in correctly. Let's see here. So in my function, I forgot to end my pi over 5, so I'm going to go down here in my function and insert parenthesis right here where I forgot it. So it should be pi over 5 and parenthesis. That should have it. Look, there we go. That's what we need it to look like. Alright, so in order to find out if the submarine was safe when it was below 300 meters below sea level, was it safe at time t equals 0? So let's go to our table of values and see when x is 0. The value of y is negative 276.4. So, since the value was negative 276.4, it was not 300 meters below sea level. So, it would not be safe. Because y is equal to negative 276.4. Okay, when t is 20 minutes, if we want to change our table set, and we have our table start at 20, we could then again look at our table of values and see that when time is 20, it was again at negative 276.4. Okay, so then we need to take a look at specific depths to support our answer, which we already did right here. So at y equals negative 276.4 when time is t is 0, that means that it was not 300 meters below sea level. It was at just negative 276.4. So between what two times is the submarine first safe? So we're going to need to now go back to our calculator, and we're going to need to enter into our calculator our next y value of y equals it's safe at negative 300. So we're going to see when we graph this that the first time it's safe is going to be pretty much where it falls below that axis. Okay, so it looks like it first becomes safe. We can zoom in to see when that is going to be hit. So if we zoom in here to our first interval, we can see here that it's going to be right after time t is 0. So we're going to want to zoom in there again. So let's zoom in right there to that axis where all three of the axes come together and both functions come together. So there's my function, there's the 300. So I want to basically find where these two lines intersect. So I'm going to go to second trace, and I'm going to go to intersect. And my first function, it's going to pretty much put it, I can just hit enter twice. And then it'll give me the first intersection is going to be at 0.150, etc. So at 0.15 minutes, which is actually some seconds. And then until I get to the other point. So let's zoom back out. Let's adjust our window again to our original settings, which our x min was at 0, our x max was at 30, our y min is what it was at negative 1100, and my y max was at 0. And then I hit graph again. I already found that first intersection point over here, and now I'm going to need to find this point here. So again, I'm going to go second trace or calc, and I'm going to do intersect. But this time I want it to intersect closer to, so I'm going to put my cursor closer over here to that point where I want it to find. So I want to find the point around this intersection. So hit enter, it will jump back up to that curve, hit enter 2 more times, and you will see that it intersects again at 7.849, which is about 7.85. So between the two times that the submarine is first safe is between 0.15 minutes and 7.85 minutes. And again, you have to use your calculator to do that. Okay, the next problem is harmonic motion, which I'm going to do a whole video devoted to harmonic motion, so check for the next video for the last problem on your review packet.